So hello everyone, welcome back to the Vansher, and in today's video we are going to talk about Perceptron. Okay, so what is Perceptron? Perceptron, P-E-R-C-P-T-R-O-N. Okay, Perceptron. Okay. So what is Perceptron in deep learning? So Perceptron is basically the building block of deep learning. You can say, okay, deep learning networks, deep learning layers. You can say, okay, deep learning models. Okay, whatsoever. These are the building blocks of deep learning models, you can say, okay, deep learning models. As you know, let me explain you with an example. Inside a body are cells are the building blocks of human body, right? Because like groups of cells combine and form, basically they form organs, right? And organs, okay, tissues, group of cells basically combine and form tissues, and then tissues combines and form organs, right? Similarly, our building blocks of deep learning models is known as perceptron, okay? Or you can say a perceptron is basically the building blocks of deep learning model. Let's see what is a perceptron, okay? A perceptron you can also call it as a single neuron, okay? Neuron. So what is this neuron? Actually, deep learning is something which is inspired by the human brain, okay? Here we have neuron, like just like we have neurons inside a brain. Similarly, we have neurons in deep learning. Okay, deep learning models. Okay, yeah. So basically, let's see a neuron, how basically a neuron perceptron basically works. Okay, okay. So here we have, let's say, x1, x2, x3. Okay, and over here, perceptron is a single neuron, okay, and yeah. So basically, let's say this has x0. No worries, I'll be explaining everything, okay. And this I'll basically pass it to something, okay, activation function, and then I'll get it. Okay. So this is a very this is a very famous diagram, or you can say this is a diagram of a perceptron. You can say, okay, how a perceptron works, okay. So basically these x1, x2 and x1, x2, x3 are my input features, okay, are my input features. Maybe I can write it like this. These are basically my these are my input features, okay, input features, okay, input features, okay. I'll be explaining everything, okay, no worries. X1, x2 and x3 are my input features, and x0 is basically a scalar, okay. This is nothing but a scalar, okay. This is something scalar value, okay. Yeah. So this is basically summation of these, okay, x1, x2, x3. But basically before finding out the sum of these input features, we have to multiply each of them with some weight, w1, w2 and w3, okay. Basically, we are multiplying like x1 with w1 and then finding the sum with x2 into w2 and then finding the sum of that with x3 into w3. Let me show you something, what I am saying. I am saying basically x1 w1 plus x2 w2 plus x3 w3, right? This is something what it is, what this is representing, okay. Basically, we are multiplying this input features with some weight, w1, w2, w3. We call this as a weight, okay. And basically, we are multiplying these and finding the sum, okay, something like this, okay. Yeah. So after finding this, we are basically passing this, let's say z, okay, passing this z to this. This is nothing but known as an activation function, okay. Activation function. This is known as activation function. What is an activation function? So basically, to be more precise, it is a non-linear activation function. Activation function can be a linear activation function as well as a non-linear activation function. We basically use a non-linear activation function. I'll be talking about why we use non-linear activation function, why we don't use a linear activation function. Okay. Okay. So this is basically an activation function. After finding out the summation of the products, we basically pass it to our activation function, and after that we get our y hat, which is nothing but our output, okay. This is our output, okay. So these are input features, like let me give you an example. Suppose you have these are input features is something like you have created a model. Okay, take this as like this. This is my model, and I am providing it something like let's say size of the house. Okay, size of house. It is my input. I am providing the size of the house to my model, and I want my model to predict the price. Okay, price, estimated price, estimated price. Okay, so this size of house is my input feature which I am passing it to my model, and it is basically predicting the price, which is my output. In this case, this is my y hat. Okay, and this is my x1. Over here we have only one parameter, basically input feature, but of course, like price of a house will not only depend on the size of the house. It will basically depend on the geography, it will depend on the locality. Okay, where the house is located, right? Of course. So yeah, and the services that are like provided in the house. Okay, yeah, many there would be many features, right? So over here I am only considering one feature. So suppose this can be any number of input features. Okay, let me erase this. I hope you have understood what I am trying to say. Okay, so these input features can be any number of input features. Now it depends. It can be only one single input feature. It can be x, so it can go to x raised to the xn. Okay, it can go, input features can go to xn. Over here, let's talk about this x0. X0 is basically my scalar quantity. Okay, we are multiplying this with some we have not included this over here. Actually, before passing this z, we do something more. We basically add this. Okay, suppose we have found all of this. Okay, and then before like suppose I am passing it to my this activation function. It will be passed like suppose this is my activation function. I am passing it to it. It will be passed in this form. Maybe I can represent this as let's say I can basically okay. What I can do is I can say it as like this. Let me represent it with something. Let's say z is my this. Okay, z plus w naught. Okay, z plus w naught, and this, let's say you can say anything. This sigma basically means I am using a sigmoid activation function. You can represent it with, let's say, a. Okay, no worries. Actually there is some word I am not getting. I'm not getting the letter. What symbol we basically use for this activation function. Okay, so this is something. Let me write the complete equation of this y hat. Okay, how it is represented. So y hat can be written as y hat is equals to, okay, y hat is equals to this x naught. Okay, before that we have what, this activation function, right? We have to pass this activation function, pass this inside the activation function. Okay, so we have this activation function. Inside that we have basically x naught plus, okay, x naught plus this entire term. Okay, of course, like I am telling you that it can go to x raised to the power n. So basically this will go to this particular thing will go to x n w n, right? So I can write this as something plus summation of x I w I, and where I equals to 1 to n. Okay, I can write this as like this. Okay, so this is nothing but my output. Okay, this is nothing but my output. Y hat equals to this. This is the activation function. Okay, we have some types of activation function I'll be talking about is like I'll be basically uploading deep learning playlists, so there I'll be talking about different activation functions. Okay? So this is one type of activation function which is sigmoid. Let's talk about this. Before that, I want to revise this once more. So basically these are the input features x1, x2, x3. It can go to xn. We are passing this to basically we are multiplying each of them with some particular weight. Let's say x1 I am multiplying it with w1, and then x2 with w2, and so on. Okay. And then we are basically finding out the sum of these, right? That's which I am calling it as z. Z equals to x1 w1 plus x2 w2, and so on till xn wn. Okay, and basically this. Okay, and then what we are doing is after finding out z, we are adding this x0. Okay, which is nothing but a scalar. And then after adding this x0 with this z, we are passing it to an activation function over here. I'll tell you why we are passing, basically what is the need of this activation function, why we are passing it, okay? Okay, so after passing it to the activation function, we are getting y hat. Y hat is nothing but an output, okay? Desired output. I'm clearing this out, and again I'm writing the entire equation fresh, okay? Just a second, clear it quickly. Okay. Yes. Pretty much done. Okay. Yeah. So the equation is something y hat is equals to, this is my activation function. I am basically adding this scalar x naught with, and I am basically finding out the summation of I equals to 1 to n x I w I, right? This was the basically expression, okay, for this, where y hat is our output. Okay, let's talk about this activation function. Okay, what is the need of this activation function? This type of this is a sigmoid activation function. Actually, this is my sigmoid activation function. Sigmoid activation function. Okay, there are many types of activation functions, like sigmoid activation function, ReLU activation function, leaky ReLU activation function. Okay, according to our need, we will be selecting the activation functions. Okay. Okay, cool. So I'll be okay. Let me talk about first of all this why we are using a non-linear activation function. Non-linear activation function. Okay, non-linear activation function. Okay, suppose I have this graph. Okay, I have some features like this. Let's say dot. Dot, and let's say this. Okay, basically there are two features. What first is the dot, and the second one is these holes type. Okay. So like suppose if I ask you to basically if suppose we use a linear activation function, so what it will do is basically it will create a this. Okay, if I want to basically distinguish these, okay, linearly, is it possible? No, because you can see these are, it is not efficiently distributing this, right. So but when we, in a case where we basically when we will be using non-linear activation function, what is the benefit of it is like it can easily differentiate, so it will create like this. Okay, something like this. So this is much more efficient than that, right? Using linear activation function. Okay. So let's talk about some types of activation functions. So we have this sigmoid. Today we will be only talking about sigmoid activation function. I am giving you just an overview. Today is just an overview. Okay. I will be creating videos on all topics. So sigmoid activation function. Sigmoid, it is a type of activation function, basically which is usually used for more of a classification, you can say classification types. When we want to classify something like dog or cat, then we use or something classification. When we are doing classification, we use mostly we use sigmoid activation function. Okay, what sigmoid does is basically it gives us the value between 0 to 1. Okay, 0 to 1. It's something like this. So if I say this as, let's say, actually the diagram does not looks good. Suppose I have this, and again it's not looking good. Not becoming correct. Not correct. Okay, I hope you understand. This is something 0.5. This is 0. Okay, it should touch like this down. Okay, this is 0, and this is, let's say, 1. Okay, so basically it compresses all the it takes any real number and it converts it in between 0 to 1. Okay, this is a sigmoid activation function. We will be talking in depth about this in upcoming videos. Okay, So I hope you have got an idea what is perceptron. Perceptron is basically it is a building block of deep learning models. Okay. So this is a very important expression. You can take y hat equals to activation function and x naught plus summation of I equals to 1 to n x I w I. Okay. Again, once again, I'm drawing the diagram x1, x2. This can go to xn. Okay, and we are basically multiplying these with some weight. Okay, this would be like w2. This would be w1, and we are passing it to summation, and then we are using this x0, which is a scalar, and we are adding that, and after that we are passing it to activation function, and after that we are getting this y hat, right? So over here, what let's say z is something like x1 w1 plus x2 w2 plus so on xn w1, right? And then before passing it to this activation function, what we do is we add this bias. Okay, very important thing I missed is like this is known as a bias. Okay, this is known as bias. This scalar is basically known as bias. Okay, cool. So when passing it to this activation function, non-linear activation function, we do it as like this z plus this x naught x0. Okay, and then we pass it to our activation function, which gives us y hat, which is our output. Okay, you can replace this x with this basically